using sets. In the second example, we are given information about 25 employees and their coffee and tea drinking. So we know that 16 of them like coffee, 12 like tea, and 5 like neither coffee nor tea. And what we're asked to find is how many like both. And remember, whenever we see the word both means intersection. So really what we're interested in finding is how many, so the number of people that like both coffee and tea, coffee intersection tea. That's really what we're trying to find. So what is it that we're given? We're provided with the total number of things is 25. We know the number of people that like coffee is 16. The number of people that like tea are 12. And we know that 5 of them like neither tea nor coffee. So what notation can we use? So we don't want coffee or tea, and we want not. So I'm going to use that not or that prime button again, and that's 5 of them. So to help us sort through this, let's draw a little diagram to visualize what's happening. So first thing, here's a circle for coffee. Here's a circle for tea. And really what we're trying to figure out this center, this intersection. I'm just going to put an X for intersection. So let's put that over here. We're going to say that is equal to some value X. We know that we have 5 people that don't like anything. So actually that's like this. If we put this on the outside here, we create a Venn diagram with that rectangle around the outside. Now we have 16 that like coffee, so really here is 16 minus X things of the overlap and 12 minus X there. So we have 2 options of how to solve this. Option number 1, solution, is to create a little equation based on the diagram that we have. We know that all of these items that are within this Venn diagram total 25. So what we can say, 25 is the total of the 5 on the outside plus the 16 minus X plus the X plus the 12 minus X. If we solve this, simplify it a little bit, we have 25 equals. We're going to add these up. So the 16, the 12, and the 5, we end up with 33. Negative X plus X and another negative X minus X. We add X to both sides and we subtract our 25. We end up X being 8. So really, there's my answer. The intersection of the 2 is 8. Second solution is utilizing formulas instead. Some of you might prefer to use formulas. You did some homework like this in the previous day's lesson. So instead of adding this into our tree diagram, let's do this. We know that the number of things that are in both we can calculate by saying there is a total of 25 people and 5 don't like either. So we know 20 people like everything. Okay, we can use this formula for union. The number of things in the union is the number of coffee drinkers plus the number of tea drinkers minus the number in both. Okay, again, this solution, option 2. Once we fill in our numbers, 20 equals coffee drinkers 16, tea drinkers 12, intersection of both, 20 equals 28 minus intersection of both. And solving this over here, we could add the intersection to both sides. Subtracting the 20 from both sides, we end up with the same answer as before. 28 minus 20, we end up with 8 as the intersection. So second method, using our formula for the union of 2 sets. Third example here, we have a Venn diagram with multiple things. So this is just getting used to learning how to read one of these Venn diagrams when we have multiple circles. Also recognizing notation. So remember, in A through E here, we're asked for the n, which is the number of things. We just want total numbers, versus F and G has a P in the front, so that's the probability of those things happening. So let's go through each one here. Union. So the first one, A, U, B, A union B means what's in both circles. So circle A, circle B, that's what you're visualizing, those two circles. We're adding up everything that's in those two circles. So when we add all our values, we get a total of 28. Next one, NS. Remember NS, total number of things. Total number of things. So total number means just let's add up all of the values that are in all of these circles. So now we have our 28. We're going to add on our extra stuff here from the rest of this. So the 28, the 4, the 3, and the 8. And we end up with a total of 43 things. So let's just add some notes again. This is total. This is union of A and B. Next one, weird notation. Brackets are important. We have this A union B in brackets, so let's think of what that is. Well, that's A and B union together, so that's those two circles together. And then the next part of this says E intersection of C. So what we're really interested in, what's overlapping with C? Well, these are the overlap with C. So if we add up all of those, we get our total. We end up with 13. Next one, number in A union D. So again, A and D. So there's my A circle. There's my D circle. Union means we want everything in both. So we're going to add up everything in A, total of 11. We're going to add up everything in D, which is 10. We're going to add those together. Notice there's no intersection here. 11 plus 10 gives us 21. Oh, look, the next one asks for the intersection of AD. Notice those two circles aren't overlapping. There is no intersection. Intersection is equal to 0. Now we're jumping to our probabilities. Probability of A union C. Okay, so new circle. We want A and C together. We want probability. So remember, probability A union C, the number of things in both. The union of C, A union C divided by total number of things. Well, look in part B. We have our total. That's 43. A union C, now we're going to add up everything that's in those two circles. When we add up everything in A with everything in C, we get a total of 30 items. You could use the formulas that we had from yesterday. Truthfully, if you have a Venn diagram, I don't think it's worthwhile trying to use the formulas. Just use the diagram. Okay, remember reduced fractions if you can. This is in reduced form, so I'm going to leave it. Probability of not B. Probability of not B. And remember, that's that little tick right there means not. So not B. Opposite of B. So there's my B circle. If we don't want B, then we want everything else. So we're going to have to add up all of these things that are not part of B. Those things added will be our numerator. So we want the number in B naught or not B divided by total number of things. Again, in this case, adding up those green highlighted, we get 22. We have our total already, 43. Again, doesn't reduce. And we're done.